Okay, so we're going to balance this equation. It's a reaction between phosphorus trichloride, which I'm representing right here, PCl3, and water producing phosphorus acid, phosphorus OUS acid, H3PO3, and hydrochloric acid. So it's interesting, this reaction makes two acids. It's clearly out of balance. What do we not want to start with? We don't want to start with hydrogen. See how it's split up? It's actually the only one that is split up on one side. Do the hydrogen last, obviously. Okay, so what should I do first? I think I'm going to start with the chlorine. Notice that there's 3 chlorine here. 1, 2, 3, and there's only 1 over there. Well, I can fix that. All I have to do, put a coefficient of 3 right there. If I put a 3 there, that means 3 of them. Now, this is not the ideal way to show hydrochloric acid. This is a bootleg way to show it, because actually it's not an ionic compound. This makes it look like it's an ionic compound. It's a polar molecule, so really, let's imagine that you can't see those pluses and minuses there. But it means 3 of the HCl's. These are all separate molecules, actually, like this. Okay, so now the chlorine or the chloride is balanced. And now we want to deal with, what else can we deal with? Well, phosphorus. Okay, notice there's 1 on each side. Don't worry about this charge shown here. That's for the polyatomic ion. Let's, again, ignore those when it's in its molecular form. Just ignore these charges. I just didn't have the right ones for this modeling. So there's 1 phosphorus on each side. That's fine. Can't do anything about that. Oh yeah, oxygen. Since we want to deal with hydrogen last, let's do oxygen. Well, there's 3 oxygen here. 1, 2, 3. Only 1 here. Well, if I multiply the water by a coefficient of 3, that means boom, boom, 3 separate water molecules. Now I've got 3 oxygen atoms here, 3 times 1, and 3 oxygen atoms here, 1 times 3. Okay, good. Last thing is deal with the hydrogen. So how many hydrogen do we have total on this side? There's 3 there, and there's 3 there, total of 6. How many hydrogen do we have over here? 6. 2, 4, 6. Boom! Sometimes one of the elements will come out in the wash. When you're balancing one, the other will just fall into place like dominoes. So that's a pretty easy one to balance. Notice it just needed a couple of coefficients of 3. And what are the coefficients here? The coefficients are invisible ones. So notice if they were all 3, we would divide through by 3, but you can't because there is that coefficient, those coefficients of 1.